Hello, good evening. We're gonna look at watching someone else their computer. So let's get some cliches out of the way. I'm sure everybody heard about this quote. There's no cloud, just someone else their computer. Well, it's funny, it's also true. And that just means that everyone who's using the cloud needs to think about how not being in control of their environment, and it impacts how they should think about monitoring. This is a very standard very standard thought process. Pets is how we used to think about servers. They each had their own name. That we knew their quirks. We cared a lot about keeping them healthy. And cattle are numbered and replaceable. So just a little bit about me. And just in case you're wondering why I'm here to talk about it, way back, back in the day, I built monitoring system for on-prem data centers, when the idea of the trust in the cloud to run your computing would get laughed at. I've been since working in and around observability, doing ITIL and ITSM, logging, metrics, and monitoring. And then for the last year, I've been with Grafana Labs, where I've had opportunity to talk to companies for tiny startups to the Fortune 50s to understand and advise the observability strategies. I've never been the smartest person in the room, but I get to hang out with the folks who you are. I've drawn heavily on the experiences of my colleagues, both in Grafana Labs, running a multi-cloud SaaS environment at massive scale, and my friends as colleagues in other companies. So some principles. Why we care about monitoring at all? Cloud providers do this for me. Well, they do it actually for themselves. You need to know where they were impacted to make an SLA case. And without that, you're reliant on what they decide. And the defaults are maybe good enough. They just give you the basics. And if you do something outside of the defaults, you need to think. You need to know what you're actually monitoring. And is this what you think it is? And of course, you need to read the manual. So where do I start? If you start somewhere, you need to pick logs. Always start there. Metrics are great. They are easily to implement and alert of you and can make pretty pictures to make the bosses happy. But logs will tell you actually what's broken. Traces are a distant third here. They are fantastically useful because they identify bottlenecks and hotspots in your environment, and they can take performance to the next level. But it doesn't matter if you can't keep your application running to start with. It's sometimes painful and messy, but you can aggregate logs together and make them work like metrics. But you can't pull the detailed tracebacks from a metric. They just don't exist. So let's get some basics here. It sounds simplistic, but it's true. We always start with the core resources. These are the things that break your whole production environment. Like things like Kubernetes, database and storage, things that you have to have working for everything else to function. Usually people manage to think about this because that's what we're looking at since the beginning of time. But also remember that the core infrastructure means things break the deployment and orchestration systems. If your CI/CD system is broken, you have a rough time deploying an emergency fix when something breaks. When talking about monitoring core resources, that doesn't mean speeds and feeds. You almost certainly, I'm going too quick. You almost certainly care about the CPU utilizations, free memory, disk space, and even health of individual nodes. Remember cattle versus pets we talked about earlier. Don't try to make a failing node healthy. Shoot it in the head and replace it. Worry about persistence and recurring failures. It makes sense to track node failures. You want the data to look at patterns, but don't alert anyone for it. You spend a lot of time and money getting into self-healing environment, so let it self-heal. Focus on symptoms and not causes. Engineers are really good at finding the cause of an issue. If you try to build that intelligence into your monitoring, you catch the things you thought ahead about of time, but not the things you didn't expect. As an aside, if you think about what impacts the users, that will guide you pretty clearly to building service level objectives, which we look at more in a moment. SLO can tell you where you're meeting expectations. Sure, but if you want to make changes too slowly, it's a great way to know if you can move faster and break things without pissing off your users. Synthetics, a simple page load test to look for a 200 response on your observability system is huge. You probably want to do this from outside of that system yourself, of course. Remember to look at all the systems as part of your observability suite. Is your alerting environment working? Ticketing if you're using Datadog, Grafana Cloud, etc., considering having a local environment ping that from time to time. And what should you use? Cloud provide monitoring varies. Cloud logging and cloud monitoring are really powerful, and you can probably after beating your head against the dogs for a while get to do what you want. This is not necessarily the case for other provider tools. UX is inconsistent and often hard to figure out in these tools. There's a ton of motivation for cloud providers to improve this, because you take what you get and you like it. You can't switch from Azure Monitor to CloudWatch or vice versa without moving your whole environment. If you are multi-cloud, tools should be two. You don't want to have learned 3 different mutually incompatible systems to monitor app. Having a solid community around your tools matter. GCP had continuous profiling before anyone else, but no one really cared about it because it wasn't talked about widely. A middling tool that you know and can get help with is much better than a tool you never heard of and can't figure out. Datadog, Grafana, Splunk, etc. have great resources online and help you out how to figure out how to do things. You can get great results out of your cloud provider tooling if you put in the effort. But again, now you're locked into the tool set, and if you want to move or expand, you're stuck. If you had that effort into learning something platform agnostic, you'll be home by now. So, and now you need to use your tools. Monitoring is only as good as the use you put to it. You can build the best monitoring systems in the world, but if nobody adopts it, it's worthless. Automatically onboarding people makes it simple for people to use. Sensible defaults, providing as part of your infrastructure, keeps logs, metrics, traces in a consistent format with a consistent naming convention. Make it simple for people who aren't familiar with the naming convention, and service to know what it's doing and what state it is. Once you get the baseline, you can build automation and tooling on top of that. Semantic conventions lead to standardization and leads to automation. Then you derive your SLO from your data without much hassle. This lets you build one SLO dashboard to see everything in the company, and enable interested parties to drill down into this. There's a simple trick I learned from our CTO, Tom Wilkie. He wanted to drive towards standardization of the SLO-based monitoring, but it's hard to get a bunch of engineers to really buy into something by just mandating it. Just think about the cat herding. So he picked a few services and instrument them the way he wanted, and start sending out weekly report to the senior leadership team and every engineer manager. After a few weeks, people started asking how can I get my status into the report. So you need to leverage FOMO. Although I've worked for a couple of startups that began in an academic setting and designed everything in pristine theoretical environment before going to the real world. So cynically, it might call this why everything you think you know is wrong. The picture explains everything. I can't say the word, infinitely scaling. This is a promise of cloud computing. And mostly you can pretend that it's true. But when it isn't, it is a disaster. Suddenly you go from not knowing or caring about the underlying infrastructure you're running onto being completely limited by it and unable to fix it. So what could go wrong? Object storage IOPS. This is part of knowing and understanding the SLAs your provider gives. Read the fine print. Do they promise performance or just writable bytes? Auto-scaling. Sure, there might be more resources available in your cloud provider, but they are the machine type. But are they the machine type you specified? Spot pricing. Someone always will pay more money for that, and you'll be outbid on your compute. And serverless isn't serverless. It's still someone else's computer. A Lambda function can fail because it's still a server instance underneath. It's running things, and hardware does sometimes break. Don't blindly assume that your serverless functions will always just work. They just need to be monitored too. If you're monitoring your environment from inside the environment, you're not monitoring. What happens when the data center goes down? Separate clusters, separate availability zones for your observability. Ensure that you have some overhead capacity. Even if you scale rate limits where appropriate, if you're running at 90%, there's a 10% plus spike that you can't scale, you're dead. Plus scaling takes time. Know which things you're going to kill first, if you have to make sure you're monitoring the critical thing. So the flip side of monitoring scaling is scaling monitoring. Sometimes I really feel comfortable, sometimes I really feel really commonly for folks who are rolling their own when they build your service environment, you probably set up scaling groups. But did you remember to set up scaling for your observability? If not, what happens when the system goes down before you have an instance? Now you really host. I might be biased, but scale your observability systems before you scale your services. It's a quick look at Facebook's war room back in 2010. This is one point where I'm going to diverge a bit and talk about tools first. It's not because processes isn't important, but because when we get to IRM, it's one area where I see people actually really think through the process first. This is awesome, but tools are still important. You already have the tools. Communication tools, where you stay in sync. Pick one and only one. Should be the same you use daily, but have a separate incident channel. Documentation tools, ideally something collaborative that you can update in real time. These are criticals and tools should be monitored. First and foremost, involve developers, you guys, in observability. This goes back to the adoption points earlier. Your developers are the one who know the most about internal systems, and thus you should have a good idea how they can fail. But you need to share a common language and tools with your production environment to be useful. The biggest mistake I can see in incident response happens way before bad codes in production. It's when someone says Dynatrace apps Splunk cost a lot of money, so we use it in prod, but not in dev. Now you have two completely different systems of monitoring and thinking about your environment. Your ops team has a set of queries and alerts, but your dev have no idea how those works. Or worse yet, you're doing DevOps and your developers spend 90% of the time in the dev environment and don't know how these prod tools. Having carried the page in past life, I can tell you that issues always occur at 3 AM, when you're half awake and not thinking straight. If you don't intimately know how these tools you have, then you struggle to make them work in an emergency. Developers should be taking the first crack at defining alerts, and you should include information about how to resolve them. This is usually best done as a runbook, rather than trying to automate a fix. Automation can hide recurring issues, and things like quick reboots can disguise the root cause of issues. Having a runbook attached to alert tells the responders the most likely place to look, but allows investigation and human intervention when appropriate. This is specific to your application, not infrastructure. You still want a pod restart when something crashes, but if you hit a crash loopback, you definitely want to dig in and understand why. Some takeaways: you need to monitor even in the cloud, because downtime costs you more than your cloud provider cares about. If nothing else, you need logs. Community: your tools are useless if no one can tell you how to use them, and they're worse than useless if nobody, you can say, in your organization uses them. Pick tools that you can use and show people what they can do and make it easy to engage. The cloud looks infinite, but it's not. Think about less obvious failures, modes, and check them. Think what happens when scaling fails and what you will do as a result. Monitor for scale, alert for user impact, nor for infrastructure impact. But scale your monitor to be sure you have the infrastructure to monitor your infrastructure effectively. And consistency is key. Use your tools and use the same tools everywhere. So this is just in closing. We have some Grafana and Friends meetup. So if you want to have some more information here. And if you want to organize a meetup, this is our own promotion. And lastly, I want to thank everybody for the attention for this slide deck. And if you got any questions, please feel free to ask them while I'm here.
We got one question.
Yeah, I got a question. Actually, yeah, thanks for a great talk. I want to ask you a question, not quite much related to your talk. I have a question about Grafana.
That's fine.
I mean, I've been building lots of solutions in my history, like data visualizations, you know, big data visualizations, and have never come across Grafana. So like I come across like different libraries which you put on top of your data, but for that you need to write your own providers.
Yes.
Custom providers. Or there is things like Elasticsearch, I think, Elastic, that it solves similar problem, I'm not sure. But yeah, can you tell a bit more about Grafana?
Okay.
How it helps to solve this data visualization problem?
Grafana is first and foremost a data visualization tools, but we're not limited to pulling the data into our own tooling. We leverage the databases or data sources from anyone and anywhere. For example, you can use a simple Google Sheet, Oracle database, MySQL database, Splunk data source, Azure Cloud Storage, GCP info. We have data connectors, which we plug into our visualization tool, and that pulls the data into our presentation. That means like we are a single pane of glass, and we can observe metrics and see similarities from all kind of data sources. So within our company, we have a big tent philosophy that we are not saying you're out of the tent. Everybody is part of the tent and can be part of our product. So your data source is available, and we can observe the data and visualize the data in any way, shape, or form, and alert on it the way you want to be alerted.
Does it absorb the data in real time?
Yes, it does absorb the data in real time, because the link is there. Once the data is changed, we can present it in real time.
All right, awesome. Yeah, thanks for answer.
Good.
More questions?
I have a question. So since Grafana is like a virtualization tool for like a CPU or scaling up stuff, so how do you monitor yourself? Because every software has their own bugs to fix or a new version to release. So how do you ensure that your product is of good quality and there's no bugs inside? Just random questions, sorry.
We run our tool in any of the cloud providers, and as I just mentioned in this presentation, we're monitoring ourselves as well. So not just our pods in Sydney are monitored from Europe, and the pods in Europe are monitored from the US, and vice versa. So we check our uptime, and we check our availability, and we get alerted when things break. So we eat our own dog food. We use our own tool to monitor ourselves. In my daily operation, we use the Grafana dashboards to monitor our own environment, and our alerts come from our own incident response management. So that's how we keep things up and running. Does it answer your question? And then on top of that, that's just on the cloud. You can also run Grafana on-prem as an open source solution. But we are not monitoring that. You need to be responsible for monitoring the own open source install. So we leave that to the customer to use their own monitoring tools.
Thanks. I have like an overview question. How does it compare to like a Datadog or like your native monitoring solutions in GCP?
We are very similar to Datadog. I'm not in sales, so there is a commercial aspect to it, which I don't know the details about. But we are on a competitor level with Datadog. Don't know numbers, so it's choose A or choose B. But for functionality, we're on par. In respect to the cloud provider monitoring tooling, that is limited within your own cloud, because you can't operate your Azure environment from Google, nor your AWS environment from Microsoft. So we are open in that. We can monitor Azure. We can monitor AWS. We can monitor Azure. So I think we're ahead of the game in that space, because we can monitor across all those cloud hyper providers.
Also, is Grafana open source? Or
yes, it is open source. Yeah, we have an open source delivery which is readily available for anyone, and then our hosted cloud instance is free for a limited set of metrics and limited set of logs. So even that is in a happy space where you can use our hosted Grafana.
Yeah, I've heard of Prometheus as well. Is that really?
Prometheus is a other open source product. We heavily rely on the use of Prometheus. I think Grafana wouldn't be as big as it was for Prometheus. So Prometheus is a metrics collector, and they are a happy marriage. They work hand in hand.
So it's like separate projects and companies.
They are separate projects, yeah.
Okay.
But we definitely have a good influence with Prometheus, and Prometheus has a good influence with Grafana, because there's daily communication between Prometheus development and Grafana development.
All right, yeah, thank you.
Okay, I just come up with another question, actually, in related to your presentation.
Cool.
I remember back in the days, like before all this cloud hype and everything, dev teams would actually build their own solution. Imagine like a monitor on a wall, right? And they would monitor whatever operations, like critical APIs, of their system. So does that solution sounds reasonable these days? Would you build something similar these days? Are there any use cases for that? Or would you fully rely on cloud dashboards, monitoring?
Let me understand the question correctly. So you want to see the presentation of your data in a war room or in a network operating center, where you can see the current state of your environment. Is that what you're asking?
So the question is custom monitoring solution?
Yes.
Versus cloud out-of-the-box solution, monitoring solution.
Or we can.
Would you build custom monitoring solution these days?
Yes.
Or would you totally rely on the cloud out-of-the-shelf monitoring solution?
No, I say keep your custom solutions. There probably are some benefits for your custom solution where you have specific scenarios what you want to see, but you can use us in combination with your custom solution. So you can keep that as a primary observability, but we can be there as an easier way to observe the data and monitor on alerts, events, or.
What are the typical limitations of the cloud off-the-shelf solution, monitoring solution?
Probably the biggest one is the privacy connectivity between the company's data and the and us in the cloud, where they say, can we trust the information sent from our prem or from our private data center into the cloud? So that's the first objection. We have private connectors, so your data is traversed securely and privately over the internet. So they take away that burden or that obstacle. Scalability, that's not an issue nowadays. That would be another objection, but I can't see that in this day and age. And then finally, when people are against the cloud, say, we're not doing anything in the cloud, we still can provide you the on-prem install.
Yep.
So our product works on-prem and in the cloud.
Right. Okay. Great. Thanks for an answer.
Hi.
Hi.
So where I'm working at, we use Grafana. And then so one thing, so like because we build it and there's like sometimes I need to change the label to make it more readable and things. My question is, nowadays we have the Gen AI, a lot of things we talk about. Do you have any, I guess, any things that you start implementing on that side of things into Grafana so that it's more user friendly or, yeah.
So you're saying the labels?
Oh, just as you talk, I was just thinking because when I work with Grafana, you know how we put in the SQL and then it would generate the label and stuff. Sometimes I need to manually go in and then change it myself. Say how this is what it means. Is there any? It's just a random question. Is there anything that you guys are start using from the Gen AI and?
Yeah. From what I see, I'm a year with Grafana, and the year where I came from. In the beginning, building dashboards was complicated. It needs a lot of hand-holding, writing the queries. You need to know what you're talking about. You need to be familiar with Logquell or PromptQuell or TraceQuell. But over time, we provide a lot more info when you're building out your dashboards. So there's actual information bulletins or documents how to do it. And in our latest release, we are much more advanced, and we built out the queries as based on the information you want to pull out of your data. So you put your label in, it populates it, and you select the identities, and then you can put more queries in. So it builds it out as you want to write the information. So this is coming in the next couple of weeks. So I can see in the last year huge improvement over the usability in the user interface. Where it was before clunky, now I think we're in a good space.